Hi, today I'm teaching you how to write molecular equation, complete ionic equation and net ionic equation. Let's take an example of one equation and see how we write these three equations. Writing molecular equation, complete ionic and net ionic equation is very important that you know it. So first, let's take a reaction between lead nitrate and potassium chloride. At the beginning of writing any type of equation, what you need to know? You need to know how to write lead nitrate. Lead is Pb, nitrate is NO3. So I write Pb NO3, lead, which is lead nitrate, twice, lead is twice, and then the medium, it's in aqueous state plus potassium chloride, KCl, again aqueous medium. These two. Now think about the solubility rules. Lead is a lead nitrate. Any nitrate is soluble. KCl, potassium is group 1. Anything in group 1 soluble. These two reactants react and you need to predict the products. That's the next step. How do you predict the products of these two reactants? Anytime, whenever you have to predict the products of exchange reaction, the meaning itself says it exchange. Cation of one reactant goes with the anion of the other reactant. So if you take lead nitrate, you have two, one cation and one anion. Think about what is cation in lead nitrate and what is anion in lead nitrate. Always metal is a cation, electron donor. Anion is negatively charged and also it accepts. So in this lead nitrate, I can write Pb 2 plus as cation. And what is the anion? It's a polyatomic anion nitrate, NO3 minus. I have anion and cation and anion in this species, and I look at potassium chloride. What is cation? K plus is the cation, Cl minus is the anion. Once you identify cation and anion of each, cation of one species goes with the anion of the other. So cation lead goes with Cl, form lead chloride, PbCl. Can you stop from there? No. You need to think, okay, Pb is 2. So Pb charge goes under chlorine. Chlorine is 1. So there's nothing comes under lead. PbCl2. Think about the solubility rules. Solubility rules, all the halides are soluble except silver, mercury, lead. This is lead, so this is soluble. And then the other one goes KNO3, potassium nitrate, aqueous. So this is the reaction, and then you can't stop from there. You need to balance the reaction. PbCl2, you have one chlorine here, two chlorines. In order to balance, you put 2 in front of it, and then you have two potassium, one potassium, you put 2 in front of it. Now let's look at one lead, two nitrates. These two relevant to this nitrate as well. 2 nitrates, 2 potassium. Equation is balanced. So this is how you write complete exchange reaction. Once you write complete exchange reaction, you can use this one to write the complete ionic equation. So in next step, let's see how to find the complete ionic, how to write the complete ionic equation. So the equation I have the balance equation of the reaction between lead nitrate and potassium chloride. In order to write the complete ionic equation from molecular equation, you have to decide the products and then you balance the equation. And also you need to know the states of each reactant. Lead nitrate is aqueous state, potassium chloride is aqueous, lead chloride solid, and potassium nitrate it's balanced. Now I am writing complete ionic equation. In complete ionic equation, I know what is the, you separate any aqueous species, you can separate into ions. So lead nitrate, it is Pb 2 plus aqueous plus NO3 minus aqueous. How many nitrates? 2. So you can't forget this 2, so you put 2. Plus potassium 2K plus chlorine, this 2 Cl minus aqueous. This is important. But lead chloride solid. Can solid separate? Solid means you mix 2 liquids. Here you mix 2 clear solvents, you form a solid. That means solid is not separate into its ions. This is the important step. When you write the complete ionic equation, you can separate these 2 ions. You need to leave it as such. So you write PbCl2 solid plus 2 potassium. You can separate because it's aqueous. Plus 2NO3 minus aqueous. So this is the complete ionic equation. This is molecular equation. This is complete ionic equation. And then I'm writing net ionic equation. How do you write net ionic equation? In net ionic equation, what you need to do, in net ionic equation, you look at complete ionic equation. You get complete ionic equation from molecular equation. So you have the complete ionic equation. You look at the spectator ions. What are the spectator ions? Spectator ions is the ions present in both reactant and product side. You can cancel out the spectator ions. Why? Because if you see the ions present in the both sides, that means these are not involved in the reaction. Spectators, they're just watching the reaction. So let's try to find out the spectator ions. Is lead a spectator ion? I see Pb2 plus here. Do I see lead 2 plus in the product side? I do not. I see lead chloride in the solid. So it's not a spectator ions. NO3, I see 2 NO3 this side. Cancel out. Potassium cancel out. So my net ionic equation is Pb2 plus aqueous plus Cl, I forgot this 2, okay. 2Cl minus aqueous goes to PbCl2. So this is the net ionic equation. So in this section, we learned how to write molecular equation, complete ionic equation, and from there we got net ionic equation. Always keep in mind, to write the molecular equation, you need to know how to write each chemical formulas, and then you determine the products by looking at cations and anion in each reactant, and then you balance the equation. Once you balance, you write the complete ionic. When you write complete ionic, keep in mind you can dissociate only if it is aqueous. You can separate if it is a solid or even the liquid. And then once you have the complete ionic, you find the spectator ions. Once you identify the spectator ions, you can cancel out and you can write the net ionic equation.